Good afternoon, and welcome to NASA's What's on Board briefing for the agency's Commercial Lunar Payload Services, or CLPS initiative. I'm Nilüfer Ramji from NASA's Office of Communications. Today's briefing will cover NASA's science investigations and technology demonstrations on board Intuitive Machines' first flight to the moon. This briefing will address the significance of this CLPS flight and highlight the NASA-provided instruments flying aboard Intuitive Machines' Nova-C lander named Odysseus. Our briefers today are Joel Kearns, Deputy Associate Administrator for Exploration and NASA's Science Mission Directorate at NASA Headquarters, Deborah Needham, Program Scientist in the Exploration Science Strategy and Integration Office at NASA Headquarters, Chris Colbert, Program Manager for NASA's Commercial Lunar Payload Services at NASA's Johnson Space Center, and Trent Martin, Vice President of Space Systems of Intuitive Machines in Houston, Texas. First, we'll start with some initial remarks from each of our briefers today before opening it up for questions. We'll be taking questions on our phone, so if you've joined us today, please press *1 to add your name to the queue to ask a question. We'll now begin with opening remarks from Joel Kearns. Joel?
Thank you. As Deputy Associate Administrator for Exploration and NASA Science, I'm also Program Director for NASA's Lunar Discovery and Exploration Program. That is, NASA's program of moon science using both robotic missions and future human missions to the vicinity and surface of the moon. I'm really excited to say that in February, America will be taking another step to science and commerce on the surface of the moon. Intuitive Machines is ready to launch their first mission, and as part of that mission, they will carry NASA science to the moon's surface. Remember, NASA is contracting with American companies to take NASA's scientific and technology and engineering demonstrations from Earth to the moon, land them on the moon, and send our data back to Earth. This is part of NASA's efforts to use commercial services and public-private partnerships. We wish to take advantage of the innovation and entrepreneurship of American private industry to accomplish these goals. Commercial Lunar Payload Services, called CLPS, uses fixed-price service contracts, not traditional NASA spacecraft development contracts. And these lunar missions are the company's missions, not a NASA mission. What we've asked industry to do, which is to soft land and operate on the moon's surface, is not easy at all. It's extremely difficult, as you probably have seen from recent lunar landing attempts just in the month of January. And doing so by a service contract brings new lessons that we're also all learning. In CLPS, American companies use their own engineering and manufacturing practices instead of adherence to formal and traditional NASA procedures and NASA oversight to fly their own missions to the lunar surface. CLPS is a test of that philosophy. Already, though, the NASA CLPS effort has generated great progress on generating 5 new types of lunar landers and a whole supply chain of high-tech parts suppliers to allow production of lunar landers, which didn't even exist before CLPS started. And a strength of NASA contracting with different CLPS companies for different cargoes of NASA payloads to be brought to the moon is that those companies exhibit different strengths, approaches, designs to land on the moon. The upcoming year is definitely going to be exciting, and after February, we expect more CLPS launches and landings in 2024. Thank you.
Thank you so much, Joel. We'll now hand it over to Deborah Needham. Deborah?
Thank you so much for having me here today. I have had the privilege of working with the NASA project scientist, Dr. Sue Lederer, and the NASA instrument team throughout the integration process for Intuitive Machines' first mission, IM-1. The 6 NASA instruments on this delivery are conducting investigations ranging from demonstrating techniques to promote safe and precise landings to how engine plumes and celestial radiation modify the lunar surface. Before I give you an overview of the science payloads, I'd like to tell you about the landing site. The landing site for this mission is Malapert A, an impact crater within 10 degrees latitude of the moon's south pole. Looking towards the south pole from Malapert A lies the tallest peak on the moon, Malapert Mountain, some of the coldest regions of the moon in the permanent shade of Cabeus Crater, previously investigated by NASA's LCROSS mission, and the destination of NASA's upcoming Viper mission, Mons Mouton. The South Polar region is important for NASA as it's where the agency plans to send future Artemis crewed missions. The instruments aboard IM-1's mission will help NASA better understand the environment in which Artemis astronauts will live and work. Now let me tell you about the 6 NASA payloads on board IM-1. The Navigation Doppler LiDAR, or NDL, is a laser-based sensor that will help the spacecraft determine how far above the surface it is and how fast it's moving. After arriving at the moon and heading toward the landing site, NDL will provide real-time navigation to help guide the spacecraft precisely to the intended landing location, leading to a gentle touchdown. The principal investigator of NDL is Dr. Farzin Ansarshurian, and the instrument was developed out of NASA's Langley Research Center. Next, the Radio Frequency Mass Gauge, or RFMG, is a space-age fuel gauge to measure the amount of cryogenic propellant in spacecraft fuel tanks like those in IM-1's Nova-C lander. If you think about your car's fuel gauge, it's very useful for knowing when to refuel, but that technology won't work in the zero gravity of space, where fluid does not settle to the bottom of the tank. Future spaceflight missions using cryogenic propellants can potentially take the guesswork out of monitoring propellant reserves and save fuel by using this technology. The principal investigator of RFMG is Dr. Greg Zimmerly, and the instrument was developed out of NASA's Glenn Research Center. Next, the Lunar Retroreflector Array, or LRA, is an array of 8 retroreflectors that will enable precision laser ranging to determine the distance from an orbiting or landing spacecraft to the LRA on the lander. LRA is a passive optical instrument and will function as a permanent location marker on the moon for decades to come. The principal investigator of LRA is Dr. Xiaoli Sun, and the instrument was developed out of NASA's Goddard Space Flight Center. Next, the stereo cameras for lunar plume surface studies will record effects of engine-plume interactions with the lunar surface and investigate how dust kicked up by the plume affects the landing vehicle and lunar surface. The goal is to understand how the landing event changes the lunar surface topography to help future landers safely land on the lunar surface. The principal investigator is Michelle Monk, and the instrument was developed out of NASA's Langley Research Center. Next, Lunar Node 1, or LN1, will transmit navigation and communication radio signals to guide incoming and outgoing vehicles with precision in an overall effort to reduce the amount of fuel required for future safe landings. The principal investigator of LN1 is Dr. Evan Anzalone, and the instrument was developed out of NASA's Marshall Space Flight Center. And finally, radio wave observations at the lunar surface photoelectron sheath, or ROLSES, has 4 antennas that will measure the density of the electrons ejected from lunar dust by photons of sunlight, as well as detect radio emissions from the Sun, Jupiter, and Earth's aurora, and dust impacts that can all influence the environment that future science instruments and Artemis astronauts may experience while working at the lunar surface. The principal investigator of ROLSES is Dr. Nat Gopalswamy, and the instrument was developed out of NASA's Goddard Space Flight Center. These are the 6 NASA payloads aboard IM-1, and I very much look forward to sharing with you the data they return from IM-1's operations on the lunar surface. Thanks, Nilofer.
Perfect. Thank you so much, Deborah. Next up, we have Chris Colbert. Chris?
Good afternoon, everybody. Thank you for joining us. As Joel noted, we've had some recent demonstrations that show just how hard it is to land on the moon. Engines, navigation systems, radios, and many other critical subsystems all have to work to enable a soft landing, and they have to do that without human intervention. But even when you have a soft landing like Japan accomplished, things can go wrong. So beyond the technical challenges, there are also significant logistics and management challenges to get all the parts purchased, manufactured, tested, and ultimately assembled into a lunar lander. It's quite an accomplishment when the vendor even gets to the launch pad. And it's one thing for the resources of a national agency such as NASA to handle all these management challenges, but we're asking commercial companies with a fraction of the size and resources to solve both the technical challenges and the management challenges. Over the last 4 years, we've been very pleased and impressed with how Intuitive Machines and our other Eclipse vendors have responded to these challenges. They've brought innovative solutions to the table, and we believe they have made reasonable choices about managing risk during the missions. But as we recently witnessed, these commercial missions can still fail. Spaceflight is a very unforgiving business, and even small mistakes can have huge consequences. We now have some firsthand experience with an unsuccessful commercial landing, but NASA leadership remains committed and continues to accept that the risk that some of these missions might not succeed. But it's important to note, even before we've successfully landed on the moon, we believe CLPS has already had an impact on the commercial infrastructure that's needed to establish a lunar economy. We've enabled new supply chains that will benefit the entire aerospace industry. DoD will have access to thrusters that were not previously available. Traditional aerospace players will be able to buy new types of tanks. The entire industry will have access to the thruster stands that didn't previously exist. These companies are not just building landers to deliver new NASA payloads to the moon. They're bringing their innovative ideas to bids for work on DoD projects and other NASA work, and on commercial opportunities that we couldn't even envision 5 years ago. These companies are now viable partners in the aerospace industry. We're very proud of what they've accomplished. Even before we achieve our primary goal of delivering payloads to the moon, CLPS is helping to establish a lunar economy led by American companies. Back to you, Nilofer.
Thank you so much, Chris. We'll now hand it over to our CLPS provider, Intuitive Machines, and Trent Martin. Trent?
Thank you, Nilofer. I'm excited to be here today representing Intuitive Machines. Today, the Intuitive Machines team worked with our launch provider, SpaceX, to encapsulate our IM-1 Nova C class lunar lander, which we call Odysseus, inside the Falcon 9 payload fairing. As our combined team closed the two fairing halves, I saw the lunar lander for the last time on Earth. Since 2019, Intuitive Machines has been developing, building, integrating, and testing every single aspect of this vehicle. The lander is a custom designed, made with state-of-the-art technologies like our never-before-flown in-space cryogenic liquid oxygen and liquid methane rocket engine, built in-house cryogenic valves and reaction control thrusters, our first-of-a-kind composite overwrap pressure vessel with a composite liner instead of a metal liner to save weight, and our navigation pods that combine optical cameras, inertial measurement units, star trackers, and laser rangefinders to ensure that we can not only find our landing site, but safely and autonomously land while avoiding hazards on the moon. Just getting to this point, we believe these achievements and innovations that were developed under the NASA CLPS initiative immediately impact the future of lunar exploration. We understand and welcome the responsibility of our IM-1 mission as we hope to become the first commercial company to successfully land on the moon and the closest landing ever to the lunar South Pole. The hopes and dreams of our customers, employees, their families, our shareholders, and the lunar aspirations of the entire country are encapsulated and ready for launch. Ad Lunam Odysseus.
And thank you so much, Trent. And thanks to our briefers for those initial remarks. For awareness, we also have some additional NASA subject matter experts on the line in case there are some specific science investigation or technology demonstration questions that come up. We'll now open it up for questions. Again, for those of you on the line, please press *1 to submit a question. Once your name is called, please state your name, affiliation, and to whom you'd like to direct your question. If you find that your question has already been answered, please feel free to press *2 to withdraw it. Let's start with Gina Sinceri from ABC News. Gina, your mic is now open.
I'm not sure who is the right person to answer this, but as you pointed out, Peregrine and Slim both had challenges. You're a different launch vehicle, a different spacecraft, a different company, but what, if anything, have you learned from their experiences?
Yeah, I'll take that. This is Trent Martin with Intuitive Machines. We learn lessons from all of our counterparts that have come before us, partners in advancing lunar exploration. We look at what the failures were that they've had. We look at our systems along the way and ensure that we've at least thought about those systems, thought about what the failure was, ensure that we hopefully will not suffer the same failures that they did. Spaceflight is hard. A million things have to go right, and if one thing goes wrong, you can still have a failure. So I can't say that we've solved every problem, but we certainly have looked at as much as we can to the lessons that we've learned over the last 4 or 5 years as various missions have attempted to land on the moon.
Thank you, Trent. Joel, is there anything that you'd like to add to that question that Gina asked?
Well, I would add that I think we're fortunate that both the American CLPS vendor and also JAXA, the Japanese Space Agency, have been very open and transparent with the public about what happened during their missions. And I think that helps other companies like Intuitive Machines and some of the other companies that participate in CLPS do what Trent just talked about, which is really understand what happened and make sure, or try to make sure that in their approach that they wouldn't fall to the same issue.
Thank you. Our next question is from Irene Klotz from Aviation Week. Irene, your line is now open.
Thanks very much. Related question for Joel. Did NASA implement any additional reviews of IM-1 and the forthcoming CLPS missions in wake of the Peregrine Mission 1 problems?
This is Joel. Thank you for your question. We had standard reviews set up even before Peregrine Mission 1 that we do with all the CLPS providers. What we did is we encouraged, for example, Astrobotic and JAXA to be very open and transparent about what happened during their missions so people could draw conclusions from that. And I believe I answered your question, but could you restate it so I make sure I answer the whole thing?
Yeah, I just wanted to know if there was any additional action items, maybe is a better way to put it, as a result of the problems with Peregrine Mission 1. And also on a related note, would you consider making it part of the CLPS task orders that providers share information, lessons learned on these missions?
I would say that we're still taking all our lessons learned from this month's attempts, the attempt by the other CLPS vendor and also what JAXA reported. So we're gathering all those lessons. Yes, we have looked at particular things in other CLPS architectures coming up. Of course, we don't share that between companies. We look at it within NASA. And we're still trying to determine what we've learned from the last American attempt, and indeed what we learned from the next American attempt, because at NASA, we do learn from everything that we participate in, and we push that into the future of what we're going to do in the future.
Thank you. Next up, we have Bill Harwood from CBS News. Bill, your line is now open.
Hey, thank you very much. I think this is for Trent. Two quick questions. The window in February and then subsequent window in I would assume March. Can you give us, open and close dates for those two periods? And secondly, can you talk us a little bit about the details of the cryogenic propellant loading on the pad, the mods that have had to been done to get you guys tanked up, and kind of like when that process occurs during the countdown? Thank you very much.
Yes, so we have an exact window in mid-February and expect SpaceX to release the exact mission timing in the coming days. It's a 3-day window. In all of those days, the landing time or date will be February the 22nd. If we were to push to the March window, it is also a 3-day window, and we're coordinating with SpaceX on that as well. As far as the cryogenic system is concerned, your question was, can I explain I'm sorry, can you repeat your question for the cryogenic system?
I'm just trying to understand what you guys had to do to make that happen. In other words, and also when in the countdown, the propellant flows. I mean, obviously, I know when SpaceX fuels, but I'm wondering just what the procedure is for your machine. Thanks.
Yeah, so thank you for that question. SpaceX added a very specific system in order to fill liquid oxygen and liquid methane at Pad 39A. They have been doing testing on that system and proven that it can fill liquid oxygen, liquid methane up to the payload, to the lunar lander in the payload fairing. That occurs prior to SpaceX filling their rocket.
Thank you for that question. Our next question is from Jonathan Seary at Fox News. Jonathan, your line is now open.
Yeah, thanks so much for doing this telebriefing. My question is probably for Deborah. A recent paper published in Planetary Science Journal identified potential landing sites for Artemis missions in the South Polar region being especially vulnerable to quakes and landslides. I'm wondering if this has any impact on this mission, either for this individual spacecraft or what it will be researching in the landing site? Thank you.
Thank you for your question. So the landing site for Intuitive Machines is on a flat surface, so it shouldn't have too many concerns regarding landslides or things like that for Intuitive Machines. So this landing shouldn't be subject to landing slides. And as for moonquakes, those are certainly from previous Apollo data. We know that those are common occurrences on the moon, but we don't expect those to be severe enough to impact the operations for Intuitive Machines.
Thank you so much. Our next question is from Jeff Faust at Space News. Jeff, your line is now open.
Good afternoon. A couple of quick questions for Joel or Chris. What is the current dollar value of the CLPS task order for the IM-1 mission? And also, what's the dollar value of the NASA payloads flying on IM-1? Thanks.
Chris, would you answer that?
Sure. So let's see. I believe the current dollar value of the IM task order, if I remember right, is $107 million. And the payloads, these were from our first round of payload selections from inside the agency. I think the total dollar value was in the range of $10 to $11 million, if I remember right.
Hey, Chris, why don't we confirm that to get Jeff a confirmed dollar amount on each of those? I think, yeah, the order of magnitude I concur with.
Jeff, I have the numbers in front of me. The value of the contract, Chris is close, it's $118 million. All right.
Thank you, Mel.
No problem. I just wanted to clarify that point. The next question we have today is from Issam Ahmed at AFP. Issam, your line is now open.
Yeah, thank you. I think the landing date was mentioned. Do you have a specificity about the launch window of mid-February, which particular date? And did you say for the contract amount that was 118, i.e. 118? Thank you so much.
So we work, this is Trent with Intuitive Machines. We work directly with SpaceX before we announce the exact launch dates and times. So that will be announced here in the coming days. Whichever day we launch, and we have a window that we're working with SpaceX, we will land February the 22nd.
I think that next part of the question would go to you, Joel. And Issam, if you'd like to repeat your question for Joel, I think he would welcome that too.
Audio clarification. I think the total value of the contract, I believe it was $118 million. I just wanted to confirm that, 118?
Yeah, that's correct. That's what Milford stated, yeah.
Thank you.
Perfect. The next question we have today is from Marcia Smith at Space Policy Online. Marcia, your line is now open.
Thanks so much. I have two questions. One is, how many days does it take to get from launch to lunar orbit? And the other question is, what is the landing accuracy? And, you know, the Japanese put out their list of criteria for minimal success, full success, and extra success. Do you have a list like that? And is the landing accuracy part of that criteria of success?
I can take the first part of that question, which was how long does it take to get from launch to lunar orbit? It actually depends on the launch day. In any case, we get to lunar orbit around a day before we land. So we would reach lunar orbit around February the 21st. And the second part of the question? Can you repeat?
rotating, and is that part of your criteria for success that you land within a certain number of meters of your spot?
So there is a requirement in the CLPS contract that we land within 100 meters of the landing spot that we've chosen. We believe that our navigation system that we've developed at Intuitive Machines is capable of landing within that circle, and we will find out next month for sure.
Thank you so much. Our next question comes from Joey Roulette at Reuters. Joey, your line is now open.
Thanks. I kind of have a general payload question for Joel or Chris. For the Moonlander payloads that are like purely commercial and have no real like scientific function or value, like marketing materials or human ashes, as was on the Peregrine lander, what's the kind of overall value, if any, that those payloads serve kind of in the general context of these commercial Moonlander missions? And is there anything that, I guess, shouldn't ever go to the moon? Thanks.
Well, this is Joel. First, I think you have to address any questions about the non-NASA payloads on Intuitive Machines' mission to Intuitive Machines. You heard from Deborah Needham about the 6 NASA scientific and technology instruments that NASA is paying Intuitive Machines to take to the moon and get data back from. That's what we're talking about today. For your other question about are there things that shouldn't go to the moon, NASA has tried to leave it up to the commercial companies to go get paying customers for their lunar missions because we want to really try to grow the lunar economy and have these companies be successful. We haven't set up guidance on things that people shouldn't do in their missions. We have focused on contracting with people to do the things we want to do on the missions. That is the NASA science and technology. Now, I will tell you, after the last CLPS company attempt, there has been an increased discussion in the U.S. government about are there things, for example, that was brought up in the earlier January mission. Should the U.S. government have a policy on that or not of taking things to the moon? And I think that's still being discussed by government agencies coming out of that whole discussion about the last mission.
I can answer a little bit of the question about commercialization of the missions. The whole point of the commercial lunar payload services approach is that we're trying to find a way that NASA can get missions to the moon without having to pay for the entire mission to the moon. So that allows us as commercial companies to go open up that market to commercial companies, individuals, universities, other space agencies from other countries that are interested in flying things to the moon, thus reducing the price to the U.S. taxpayer. As an example, Columbia, the sporting goods company, we have a partnership with Columbia on our first 2 missions. We're not only flying the Columbia logo and talking about Columbia as part of our sponsorship, but they're actually doing an experiment where they're taking the material that they use in their jackets that they sell here on the Earth. We're using it as a thermal insulator on our IM-1 mission and our IM-2 mission. And because of that, they've actually been able to reduce the weight of their jackets that they sell here on the Earth by I think as much as 30%, if I remember correctly what they said, through their OmniHeat Infinity technology that they're using. So it drives innovation that's independent of what would typically be considered the aerospace market. And as a former NASA employee, and I have regular discussions with companies that I never thought I would talk to when it comes to aerospace, simply because of the way that we do things with this CLPS approach.
Thank you. Next up is David Curley from Full Throttle. David, your line is now open.
Thank you very much. To the NASA team, very different science was on the astrorobotic mission than what is on this mission. You were trying to learn different things from these 2 missions. Can you talk about where you are now and where you want to go and what you have to do to make up for the science that you had hoped for the astrorobotic mission? Thank you.
This is Joel Kearns. I'll address that, and then I'll invite others like Deborah Needham to also comment. For the initial commercial lunar payload services missions, NASA assembled a complement of scientific instruments and technology developments and engineering tests that we could contract with industry to go take to the surface of the moon on their initial attempts. And we, each of these instruments will gather valuable data after they successfully land, in some cases even in transit to the moon. But we never, and in some cases we bought multiple copies of some instruments, and it's because we thought we might like to land them in different locations and get data to compare. And in other cases, we only bought one copy. But again, for these early missions, we knew that there was substantial risk that some of the missions might not be successful, and we did not plan to build additional copies of instruments and fly them on additional future CLPS missions beyond what we had already laid out to do several years ago. We are, for the later CLPS missions, the ones that start later in 2024, we have larger, more sophisticated instrument suites that will really tackle very detailed scientific questions, and they will fly to particular places on the moon. But we don't routinely plan to build backup instruments or tell people that if there's an issue on the mission that they're assigned to, that they will fly again in the future. We look at that kind of in a case-by-case basis. Let me turn it over to Deborah Needham if Deborah would like to comment, or anyone else on the speaker list. Deborah?
Thank you, Joel. Yeah, just to underscore what Joel said, the previous flight did collect some very valuable data that we expect to use and for maturing the payloads for going forward to the ones that do have a second manifest planned in the future. So, and the payloads from before also could characterize the environment in cislunar space in some ways too. So we're looking forward to the data that came from those. We do stand to learn quite a lot from even the data that was collected. And for the instruments that are coming on Intuitive Machines delivery, we're looking forward. These were intentionally selected to be somewhat site agnostic, but NASA sees a great opportunity in characterizing this specific South Polar region in advance of preparing for the upcoming Artemis missions to the South Polar region. So we're looking forward to the data that we stand to collect from these early payloads.
Next up, we have Michael Greshko from Scientific American. Michael, your line is open.
Thank you all so much for doing this. This is a question, I think, for the NASA folks. This represents, obviously, the first CLPS mission to attempt a South Polar region landing. There's going to be a lot of activity in this region. China recently announced the Chang'e 7 mission would be targeting a peak near Shackleton. Of course, Prime 1, Intuitive Machines' upcoming mission, targeting this region. And on top of all of that, we're still waiting on a down select for the Artemis 3 landing site. So with all of this heightened activity around the South Polar region, how is that going to influence the further selection of CLPS landing sites, and how will you all be evaluating the performance of Odysseus at Malapert A in kind of informing the siting of future CLPS missions in the region? Thanks.
Well, this is Joel Kearns. I'll give an answer, then I'll ask others like Deborah to comment. So within NASA, of course, we do coordinate. First off, for the individual CLPS task orders that we give industry, particularly after the first couple of task orders, we tell industry where we want them to land our NASA scientific and technical equipment on the lunar surface based on the goal we have or scientific investigation that's been selected to take certain measurements. And we coordinate that within NASA with our internal body that looks at the landing sites at the South Pole for our Artemis crewed mission so that we understand, are we sending a robotic, are we asking a company to send their robotic explorer to a place that in the future we will send astronauts? I will say that the moon is a really big place. There are a couple places at the South Pole, there are more than a couple that are of great interest, both the scientists and the entrepreneurs, people that have particular applications in addition to science. So we do coordinate that internally at NASA, so we're all aware of where everyone's going. I would also say that, you know, the United States is a signatory to the Outer Space Treaty, and all the signatories to the Outer Space Treaty have to inform each other about where they are sending things in space, including very moon. I don't know if that answered your whole question, but I was going to see if Deborah or Chris or anyone had anything else they wanted to add to that.
Yeah, thanks, Joel. This is Deborah. I'll add a little additional context for lunar science. Our agency objectives, science objectives, are broad in terms of where on the moon we can address them. So there are very high priority science objectives that we can address at the lunar south polar region, but there are also high priority science objectives that are only achievable away from the south polar region. And this is one of the great benefits of CLPS, is we get access in the near term to locations across the lunar surface that can address our high priority science objectives. And I don't know if Chris also wants to add anything. I can send it over to Chris.
Sure. No, I agree with everything Deborah and Joel said. I would just add, you know, as Deborah noted, one of the purposes and one of the goals of CLPS was to take as much advantage of commercial capabilities as we could, which hopefully yields lower costs and lets us send missions to a lot of different parts of the moon. Human exploration will be fairly focused on the South Pole, but as Deborah noted, there are science objectives all over the moon that are important and interesting. So CLPS should give us an opportunity to explore those at a reasonable price, and we've already got CLPS missions scheduled for the South Pole, for near the equator on the near side, on the far side. We're already going a lot of different places on the moon.
Thank you so much. And we have time for one last question. Our last question is coming from Issam Ahmed from AFP. Issam, your line is open. All right, I think Issam, are you there?
Oh, hi. Sorry. I think it was muted. Sorry, the first question for Trent was, are you able to share with us the total value for the non-NASA contracts? I know the NASA contract is $118 million. I was wondering what the ratio is for the non-NASA, the other contracts. And for Joel, just to piggyback again on my Reuters colleague's question, is there currently sort of no veto whatsoever that NASA has on these payloads? So, I mean, if obviously this isn't the case here, but if a company were to take something up which is repugnant to a lot of people, NASA couldn't say no, no on that front? Thank you.
Okay. So
no, this is Joel. After Trent answers, could you repeat the question that was breaking up on my telephone?
Okay.
Go ahead.
So for the question for Trent, we don't specifically get into the cost of individual payloads and how much it's worth. I will tell you that we have 3 commercial lunar payload services contracts for 3 different missions. On those 3 missions, NASA is clearly the anchor customer on all 3 of those missions still, because there is not a large commercial market yet. I will say that market is growing, and we are finding a reasonable amount of revenue in our missions from those commercial customers.
Okay, thanks. And will someone do the NASA side?
Sam, would you mind repeating your question for the NASA side?
Oh, yeah. The question for the NASA side is just to clarify that there's absolutely no veto power that NASA can exercise on payloads. I mean, theoretically, if a commercial customer were to try to take up something which, a lot of people would find a bad idea or bad or repugnant, would NASA not have at this point any power of veto on that?
Well, this is Joel Kearns from NASA Science. I would say a couple of things. The first is that the commercial missions are regulated by U.S. government organizations outside of NASA, the FAA and the FCC. I would also say that NASA could certainly attempt to influence companies to do or not do certain things, but as you can imagine, that would probably come at a cost to NASA. It would have, a financial cost to NASA. It would have to be, we would have to assure ourselves that what we were suggesting was legal and proper to do. I'm not an expert in that area of law, but as I said earlier, because of the discussion of the last American commercial landing attempt with the issue that was brought up the Navajo Nation, I know there's a intergovernmental group that is looking at questions like that today.
Thank you, Joel. And thanks to all of you who submitted questions today. And thanks to our briefers for taking the time to discuss NASA's CLPS initiative and Intuitive Machines' upcoming mission, IM-1. As a reminder, Intuitive Machines is scheduled to launch aboard a SpaceX Falcon 9 rocket no earlier than mid-February. Thanks again for joining us. That will wrap today's briefing.